9. And today we're going to talk about two-dimensional arrays. As you can see on my camera, we're going to get started with what's a way to represent a two-dimensional array. And as you keep going through computer science, you're going to do more and more where you need to draw something and do the math and so on before you can actually write a program to solve it. So when I start getting ready to talk about two-dimensional arrays, there's two things that I like to think of. The first one is an ever popular, and this is an area of math that some of you have gotten to, some of you haven't, and it's one of those where a matrix, and you start doing a lot of different things with matrices. In CPS 162, we just did matrix multiplication. So there is some math background. As you go through these courses, you'll see that you need. And you know, some of you have already done work with matrices. You've all had college algebra, so hopefully you saw some matrice work, Gaussian elimination, some words like that come into play. Another example is tic-tac-toe, where I have a 3x3 grid, and you know, I can fill it in, and we'll take a look at that example in a minute. But when it comes to working with matrices, first thing I need to do is, how do I declare this two-dimensional matrix? And it's almost exactly like it was with the one-dimensional matrices, in that when I set it up, I say I want a matrix. I'm going to call it matrix A. It's going to be an integer two-dimensional array. Once I tell the computer what it is, I'm going to say, okay, now I need a matrix that's going to be of size 3x3. And again, when we have the size 3x3, we know we want to be using subscripts 0 to 2. Now, a good way to think of a two-dimensional array, like a matrix, is to start talking about rows and columns. And if you take a look here, I have row 0, row 1, and row 2. And in my columns, I have column 0, column 1, and column 2. So if I happen to look at this 7, 7, it's going to be located at matrix A, and the subscript would be row 2, column 2. And that would allow me to reference that actual 7 that you see there. Okay? So instead of dealing with one subscript, I now have 2. Like I said, the best way to think about it is row and column. Now you typed in a code listing. It was code listing 718. And one of the things you saw in 718 is this nested for loops. I have a for loop, and then the very first thing I do inside of it is I have another for loop. So in this case, when I cycle through, and if I was doing a little like hand tracing this program, row gets the value of 0, then we come into the inner loop, column gets the value of 0, does whatever it does inside of here, column gets the value of 1, and it'll repeat this inner loop again, and then column gets the value of 2, and it would repeat this inner loop again. Now that it completed all the work for this inner loop, it's going to jump back up to this 4, and now row gets a value of 1, and I'm going to repeat the process of this inner loop. So now a second time, column is 0, column is 1, and column is 2. I jump back up, row gets a value of 2, and I go through 0, 1, and 2 again. So this body inside of this loop gets executed how many times?
3 times.
Nope.
9.
It's good. 9, right? So it's going to be 0, 0, 0, 1, 0, 2. Is my camera lagging? Or is it smooth?
A little bit.
Yeah. What's going on with that? Anyhow, 0, 0, 0, 1, 0, 2. 0, 0, or excuse me, 1, 0, 1, 1, and 1, 2. And then finally 2, 0, 2, 1, and 2, 2. 2, 2. I said 2. I can't stand 2 2s. Well, let me give you another example. What if I did something like this? For row equals 0, row is less than 10, row plus plus. And now I did a second loop for column equals 3, column is less than 8, column plus plus. How many times would that loop execute? Row is 0 to row less than 10. Column starts at 3, less than 8. Well, I'm thinking that row is going to start at 0. Column is going to go from 3 to 4 to 5 to 6 to 7. So my inner loop is going 1, 2, 3, 4, 5 times. How many times is my outer loop going to go? Well, row is from
10.
0 to how many?
10.
It's less than 10, so it's going to go 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, which is actually 10 numbers. And the inner loop goes 1, 2, 3,
50.
4, 5, 50, right? This loop's going to actually, the body of this loop is going to execute 50 times. Okay, and again, it's going to go 0, 3, 0, 4, 0, 5, 0, 6, 0, 7. Then it's going to go 1, 3, 1 up to 7. Then 2, 3 up to 7. And it's going to keep going through that with the rows getting the values of 0 to 9.
I have a question real quick.
Sure.
For like practical uses, why would you want your one loop to execute like, let's say for this example, 5 times in a row, and then the other loop executes once?
Okay. So let's flip the page, and I accidentally muted again. So here's what we have. I have an array, okay? And we're going to have a bunch of elements in this array. And one of the things we might want to do with the array is to sort it, okay? And to sort it, I'm going to put some numbers in here: 4, 2, 9, 11, 8, 3, and 7. And one of the ways of sorting is saying, okay, I'm going to start here, and I'm going to compare this first location to all the rest. And if the location that I'm comparing it with is smaller, I'd switch it. So I'd start with location 0 and say, compare these two. Would they get switched? Yes. So now the 2 would be here, and the 4 would be here. Now I'm going to take 2 and compare it to here, 2 and compare it to 11, and I'd keep going all the way out. Okay, once I'm done, I'd have a new array with 2 being the smallest item. Now I'd like to move over and get the next smallest here. So I'm going to continue this process where I start with 0, and I compared it to 1, 2, 3, 4, 5, 6. So 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, and 0, 6. Okay, then I'm going to move over to the second subscript, which is 1, and I'm going to compare 1 to 2, 3, 4, 5, and 6. So 1's going to get compared to 2, to 3, to 4, to 5, and 6. And I would keep doing that until I get to the end. 3 would get compared to 4, 5, and 6. 4 would get compared to 5 and 6. And 5 would get compared to 6. So I have this bunch of numbers, okay? Now, do you notice I have a number just like I did on the previous page, and I run through a list of numbers. Then I went to a second number and ran through a list of numbers. Then I went to the 2 and ran through 3, 4, 5, and 6. Well, in order to achieve this, my outer loop, and again, I'm working with a one-dimensional array, not a two-dimensional array, but my outer loop might be for counter 1 equals 0, counter 1 is less than 6. Oh, that should be a counter plus plus. Okay, my next loop is actually going to look kind of crazy, because when counter 1 was 0, where did this guy start?
1.
When counter 1 was 1, where did this guy start? 2,
2.
right? So I'm now going to say my second counter is actually going to start at whatever counter 1 is plus 1. And it looks like I'm going to go all the way up to 6. So counter 1 and counter 2 is less than 7, and counter 2 plus plus. Oh, I forgot a 1 there. So this now doing this, this would give me 0. This would give me 1, 2, 3, 4, 5, 6. Then I come back up. This gives me 1. My inner loop would go from 2, because it's counter 1 plus 1, 3, 4, 5, 6, which is what I wanted up here. My outer loop is 2. This goes 3, 4, 5, 6. So here's an example of where these numbers, we don't know what we're going to need, but it's a possibility that it won't be nice and clean like 0 to 3 less than 3, 0 less than 3, like it would be for that matrix. Does that help? Somebody say yeah.
Yeah, that helps. Sorry.
Okay, yeah, that's fine. That's good. Okay, so we come back up here, and as you see, in order to cycle through everything in the two-dimensional array, I'm going to use 2 for loops. Now, tic-tac-toe. Great if we had time in the class, we could work on writing tic-tac-toe, but we don't have the time. But if I'm thinking, okay, you know, how would you like to play the game of tic-tac-toe? So if I'm getting ready to play and I say to you, okay, I know in my code I'm going to represent this as a two-dimensional array, but I'm going to ask you, you are X. Where would you like to put your X? And you would tell me where.
Upper right corner.
Yeah, you need a way to describe it, but you need a way to describe it that the computer knows. So one of the things is, well, maybe I ask which row and which column, you know, but then I would have to do 1, 2, and 3 for the rows to make them user friendly, and 1, 2, and 3 for the columns. So I'd have to adjust that in the program. That's one way. Okay. What if I did something like, well, I'm going to let this be 1, 2, 3, 4, 5, 6, 7, 8, 9. That's another way. And in this way, we're only asking the user to input 1 number, not 2. So if I said to you, where would you like to put your X? You could easily answer what? Pick a number. Where would you put X?
3.
9.
3, okay? So then 3 is off the board and X. So, you know, if I was asking you to write this, one of the things you might want to do is, and I put this, fill with characters to start. Well, actually, the first thing you would almost need to do is, how do I want to lay out my table? How do I want to lay it out? You know, do I want to go 1, 2, 3, 4, 5, 6 and display the numbers? Do I want to ask them for rows and columns and a whole bunch of different things? Okay. Then you're going to, you know, ask the user, pick a value or pick a location and put in the X. And after that value is put in, what would you almost have to do next? Well, I would think you'd have to check for winner. Did anybody win? No, because there's only one X on the board, right? How would I know if they win? Well, I'd have to compare these locations. And how many different ways are there to win tic-tac-toe?
9.
Nope.
One way, like 3 ways.
Nope. How many horizontal ways? 1, 2, 3. How many vertical ways? 1, 2, 3.
6.
That's 6.
7.
And then this
8.
diagonal or this
8.
diagonal. Yeah. So there's 8 ways to possibly win. What else could be a problem on a tic-tac-toe board if you were writing this? Well, what happens if I fill it up and there's no winner? So you want to check for winner, or I guess we call it a tie. I don't know. So again, you see, I'm still not even thinking about writing any code. I'm thinking about, if I'm playing the game, how do I want to start to lay this out? What are the steps I'm going through? You know, we're filling with characters. We started with X. somehow or other, I need to know the next term belongs to O. You know, so change X or O kind of thing. I'd need to keep track of. Am I going to need a loop? Well, yeah, I'm probably going to need a loop until there's a winner kind of idea. But again, it's working with this concept of a two-dimensional array and how would I build a program. Okay, so what I want you to do now is I want you to go to D2L, and I'm going to see if I can share my screen and go to this page. And you see our final exam schedule. Again, it's right there near the top. But you also see array day 2. And if you refresh, if I refresh, what now should have popped up is and I don't see it. It's a program that I wanted you to write, and it didn't pop up. Let me see where it is. So I'm going to go in because I can go in this way. This is great preparation. Here it is. And I had it scheduled to release at 10:10, which we're not even in class at 10:10. That was supposed to be 9:10. I'm going to release it now. Come on, give me now an update. And you can refresh your screens or look at my screen. But what I'm giving you is the layout of a main to add two matrices. So if you take a look, public static void main, that's fine. Then my data type, string input. So I'm going to use that as an input if I need it. Let's see, the first thing I do is I create matrix A, it's size 3 by 3. Matrix B, it's 3 by 3. And matrix sum, which is also 3 by 3. Now, if you notice, I am going to call a method fill A, or fill. And I'm going to send matrix A in. What I want you to do is randomly fill the matrix with the numbers from 0 to 9. Now, you notice fill is being used again. This time I'm passing mat B in. I'm passing the address in. Okay? I'm using the exact same method to fill this second array. So you're going to need to write a method called fill. Then I print matrix A. So now you need to write a method called print to print out a two-dimensional array. Then we're going to reuse that to print out matrix B. Then we're going to add the two matrices. So this is a third method that you're going to write. And then finally, I want you to print out the sum. So this main is actually reusing methods, so I don't have to rewrite blocks of code. I need a method called fill that will fill the matrix that's being passed with the numbers from 0 to 9 randomly. So there's your random numbers again. I need to be able to print it just to display it in a J option pane. And then I need one that will add A and B and store it in sum. So I'm thinking in all three of these, you're going to need the nested for loops. For row equals 0 to less than 3, for column equals 0 to less than 3. And you're going to do action inside of each of those. Any questions? Okay, I'm going to stop the share. I'm going to stop the recording.